Bismillahirrahmanirrahim. Salt analysis. My name is Dr. Muhammad Imran Fakhri, and Ms. Subia Main also helped me in preparation of this lecture. In lecture number 1, we are going to discuss about the introduction of the group reagents which are being used in the salt analysis. Salts are being formed by the reaction between acid and bases. Following salts are commonly given for the analysis: copper sulfate, ferrous sulfate, aluminum sulfate, nickel sulfate, zinc sulfate, magnesium sulfate, cadmium chloride, calcium chloride, barium chloride, ammonium chloride, ferric chloride, bismuth carbonate, lead acetate, aluminum nitrate, and barium nitrate. These are the sulfate salts which contain sulfate as their anions, and these are the chloride salts. We can say we have carbonate also here, we have acetate salt, and we have the nitrate salts also present. Salt analysis is considered to be a qualitative analysis. In intermediate level, we are given only one salt, in which we have to identify the cation that is present, and we also have to identify the anion that is present. When sulfuric acid reacts with magnesium hydroxide, magnesium sulfate, and water is being formed, similarly HCl reacts with barium hydroxide to form barium chloride and water. Sulfuric acid with copper 2 hydroxide is going to form copper sulfate and water. Sulfuric acid with calcium hydroxide will going to form calcium sulfate and water. Ammonia reacts with HCl. This is a different sort of reaction, we can say. Ammonia is a Lewis base that is going to react with the acid to form ammonium chloride, while the above four reactions are between acid and bases. Similarly, when acetic acid and acid reacts with lead oxide, that is the metal oxide, they are also going to give us salt and water. Cation comes from base, anion comes from acid. In sulfuric acid, when it reacts with magnesium hydroxide, it will going to give us magnesium sulfate and water. In magnesium sulfate, the magnesium ion comes from the base, from magnesium hydroxide. That's why it is called basic radical. And in magnesium sulfate, the sulfate ion comes from the acid. That's why the sulfate ion, which is the anion, it is also called as acidic radical. Another reaction in which barium chloride is being formed. The salt barium chloride contains barium 2 positive ion as its basic radical, and the chloride ion is the acidic radical. Similarly, when ammonium chloride is going to be formed, we are going to say that the ammonium ion is the basic radical and the chloride ion is the acidic radical. When lead oxide reacts with acetic acid, it is going to form the lead acetate. In lead acetate, we have lead 2 positive ion as basic radical and the acetate ion as the acidic radical. Salt is usually formed by the reaction of acid and base. Cation comes from the base, that's why it is called basic radical. Anion from the acid, that's why it is called the acid radical. We have following analytical group of cation or analytical group of basic radical. The first group is consisting of silver ion, mercuric ion, and lead 2 positive ion. The second analytical group of cations, or we can say the second analytical group of basic radical, consists of cadmium, bismuth, copper, arsenic ions, arsenic 3 positive ion, and arsenic 5 positive ion. Similarly, strontium ions, and these all ions are present in the second analytical group. Third analytical group consists of Fe2 positive ion, ferric, aluminum, and chromium. Fourth analytical group consists of zinc, manganese, nickel, and cobalt. The fifth analytical group consists of barium, calcium, strontium. In the sixth analytical group, we have magnesium, lithium, sodium, potassium, and ammonium ion present. The first analytical group of anion or the acid radical, we have carbonate, bicarbonate, acetate, and the following ions are also present. Chloride, bromide, iodide, nitrate, oxalate is being present in the second analytical group. And in third analytical group, we have phosphate and sulfate present. Preliminary test. In preliminary test, we have to observe the state of the salt, color of the salt, and whether it may have some odor. And we have also have to observe the solubility. The salt can be soluble in water or can be soluble in dilute HCl, or it may be soluble in dilute sodium hydroxide. So we have to check the solubility of the salt. State of the salt. If the salt is crystalline, we may have chloride, bromide, iodide, sulfate, nitrate, acetate, or nitrite, or carbonate of sodium ion, potassium ion, and ammonium ion. If the salt is amorphous, we may have carbonate, sulfate, sulfide, oxalate salts of metals except sodium ion, potassium ion, and ammonium ion. Hygroscopic salts, which are colorless salts, they contain halide and nitrate of aluminum, zinc, cadmium, ammonium, or magnesium ions. Hygroscopic salts which are colored, they are chloride or nitrate of nickel, Fe2 positive ion, cobalt 2 positive ion, Fe3 positive ion, copper 2 positive ion, and chromium 3 positive ion. Inference are interpretation, suggestions, implication, and conclusion which we observe during the experiment. The color of the salt, which is being observed as blue, we may have copper and cobalt, dark green, bright green, light green. We may have the respective ions. For yellow and brown solids, we may have Fe3 positive ion. For the light pink salts, we have Mn2 positive ion. Reddish pink, we have cobalt. For the white salt, we have the following cations can be present. Some idea about the color of the salt. Their pictures are being displayed. For the observation of odor, we have to rub the salt with oxalic acid and plus few drops of water. If vinegar-like smell is being observed, then we can say the salt may contain the acetate ion. And when the salt is being treated with dilute sodium hydroxide and it is being heated up till 2 or 4 5 minutes, if the smell of ammonia comes from the test tube or the flask, we may say that the salt contains the ammonium positive ion. For the solubility, we have to take the salt and we have to add 3 to 5 ml in a test tube, uh, 3 to 5 ml water. If the salt is soluble, it may contains the following ions, or it may have halide present except mercury, silver, and lead. Their halides are not soluble in water. And we may have sulfate, but the sulfate of mercury, silver, lead, strontium, and barium cannot be there. So the sulfate of these cations cannot be there if the salt is soluble in water. If the salt is insoluble in water, we may have carbonate, phosphate, and oxalate present. And except the carbonate, phosphate, and oxalate of sodium, potassium, and ammonium, because sodium carbonate, potassium carbonate, or sodium oxalate and phosphates, these are soluble in water. So the sodium, potassium, and ammonium salts are usually soluble in water. Analysis of anions or acidic radicals. Systematic approach for the acidic radicals, and we also have to perform the confirmatory test of the acidic radical or the anion which is present in our salt. There are three group of anions we have previously discussed, and we have three group reagents. By adding the reagents, we may observe some specific smell and colorless gas evolution or colored gas evolution taking place, or we may also observe the precipitation. In first group, we have to add dilute HCl in the salt. We have to take salt in a test tube and add dilute HCl. So evolution of gas can take place if the following anion or colored gas or a specific smell being observed. So the following anions can be present. If no observation is there with the addition of dilute HCl, we have to perform the test for the second group, in which we have to take the salt in a test tube. We have to perform in another test tube. We have to add concentrated sulfuric acid. By addition of concentrated sulfuric acid, sometimes we have to heat it gently, and with the help of concentrated sulfuric acid, some smell can be observed, some colored gas evolution can be observed. So we may say that the group 2 anions can be present. If no observation is there, no gas evolution, no smell, no colored gases being formed, then we have to go for the group 3 anions, or the third analytical group, we can say, for the acidic radicals. We have to take the salt solution and we have to add barium chloride solution into it. If precipitation or some gas evolution, if precipitation is being observed, we may say that the group 3 anion, phosphate or sulfate, may be present. The original solution, or OS, stands for the original solution. We have observed that in the solubility discussion, we have a discussion that salt can be soluble in water, so that will be its original solution. If the salt is soluble in dilute HCl, so it will be its original solution, or if the salt is soluble in dilute sodium hydroxide, that will be its original solution. Anions, the acid radicals, they are present in the given salt. We have to identify them. For the first group, we have to add dilute HCl. If some observation, colored gas, or some gas evolution being observed, so we may have the following anions present. If no observation, then we have to go for the second group, in which we have to add concentrated sulfuric acid. If gas evolution or specific smell gas or colored gas is being observed, so we may have these anion present in the given salt. If there is no observation, we have to consider that group 2 anions are absent, as well as group 1 anions are also absent. We have to perform systematically. First, we have to perform the test for the group 1 anions, and then for the group 2 anions. And if the group 2 anions are also absent, then we have to go for the group 3 anions, in which we have to add barium chloride. If precipitation occurs there, we may have phosphate or sulfate present in the given salt. Group 1 anions. We have to add dilute HCl in the given salt, and if the salt contains the carbonate, we are going to observe colorless gas is being evolved. If bicarbonate was there in the given salt, with the addition of dilute HCl, we are going to observe colorless gas is being evolved. If acetate ion was present in the given salt, by the addition of dilute HCl, we are going to observe smell of vinegar. For the sulfide, if the sulfide ion is present in our given salt, then A rotten egg like smell is being observed. And similarly, some other observation can also be take place. Group 2 anions. In the given salt, we have to add concentrated sulfuric acid. If our salt contains chloride negative ion, a colorless gas is going to be evolved with pungent smell, which is going to give dense fumes with the ammonium hydroxide. We are going to say our salt contains the chloride negative ion. If the salt contains bromide negative ion, a reddish brown gas is going to be observed, or a reddish brown gas is going to be evolved with the addition of concentrated sulfuric acid to the salt. This reddish brown gas is going to be intensified by the addition of MnO2. If the salt contains iodide negative ion, violet gas is going to be observed, and its color, or it is intensified by the addition of MnO2. If the salt contains the nitrate ion, a yellowish brown vapor is going to be observed with the addition of concentrated sulfuric acid, and this yellowish brown vapor is going to be intensified by the addition of copper turnings. An odorless gas is being observed when the oxalate ion is present in the given salt. So this odorless gas will going to turn the lime water milky, which is going to confirm that the oxalate ion is present in the given salt. Group 3 anions. In the salt solution, we have to add the solution of barium chloride. By the addition of barium chloride, the salt is going to give precipitation. White precipitates are going to be observed for the sulfate if it is present in the salt, and white precipitates are also being formed for the phosphate. We have to distinguish by the addition of dilute HCl to the white precipitates. If the white precipitates with the addition of dilute HCl are not soluble, then we are going to have sulfate present in the given salt. If the white precipitates are soluble with the addition of dilute HCl, then we are going to say that our salt contains the phosphate ion. Analysis of cations or basic radicals. Cations and basic radicals are classified into 6 groups. The group number 1 consisting of silver ions, mercuric ion, and lead 2 positive ion. Group 2 consists of the cadmium, bismuth, copper, arsenic, and tin positive ions. Group 3 cations are iron 2 positive, iron 3 positive, aluminum, and chromium. We have group 4 in which zinc, manganese, nickel, and cobalt ions are present. In group 5, barium, calcium, and strontium are going to be detected. And in group 6, we are going to identify magnesium, lithium, sodium, potassium, and ammonium ions. Basic radical group reagents. In group number 1, in the original solution, we have to add dilute HCl. If precipitation is going to be occur, we are going to say that silver ion, mercuric ion, or lead 2 positive ion are present. Then we have to further distinguish these cations or perform their confirmatory test. If no precipitation occurs with the addition of dilute HCl into the original solution of the salt, then the group 1 cations are absent. We have to move towards the group number 2. In group number 2, we have to add HCl dilute in the original solution, and further we have to add hydrogen sulfide H2S in the form of gaseous state or in the gaseous state. We have cadmium, bismuth, copper, arsenic, 3 positive ion, and arsenic 5 positive ion, strontium, and stannous. We have these cations which are going to be precipitated in the form of their sulfides with the help of the hydrogen sulfide gas, H2S gas. If there is no precipitation, then group 2 cations are absent. We have to move forwards towards the group 3. In group 3, how these cations are being identified or being detected or analyzed, we have to add ammonium chloride and ammonium hydroxide in a slight bit of excess amount into the original solution of the salt. If precipitation occurs, then we may have Fe2 positive ion, Fe3 positive ion, aluminum 3 positive ion, and chromium 3 positive ion present. If precipitation of different colors may be formed, if not formed, then we can say that group 3 cations are also absent. Systematically, we have to move towards the group number 4, in which we have to add ammonium chloride, ammonium hydroxide, and hydrogen sulfide into the original solution of the salt. If the precipitation occurs by the addition of these reagents into the original solution, then we may have zinc 2 positive ion, manganese, nickel, or cobalt, which are the group 4 cations. Okay, and if no precipitation is being observed, colored or white precipitation are not being observed, this means that group 4 cations are absent, and we have to move uh, towards the group number 5. In group number 5, in original solution, we have to add ammonium chloride, ammonium hydroxide, and ammonium carbonate. If precipitation is going to be occur, then we may say that the salt contains barium ion, calcium ion, or strontium ion. If no precipitation is being there in group number 5, adding these reagents, so we have to move towards the group number 6, in which in the original solution we have to add ammonium chloride, ammonium hydroxide, and ammonium sodium hydrogen phosphate. By the addition of sodium hydrogen phosphate, if precipitation and different color precipitate are going to be obtained, then we may say that these cations are present. First analytical group of cation, basic radicals. It is also called silver group. We have to add dilute HCl into the original solution. If precipitation is going to be formed, then we may have the first group present, in which silver ion is precipitated as silver chloride, and silver chloride is white color precipitates. Similarly, mercuric ion is also precipitated as HgCl, that is also white in color. These precipitates are white in color, and similarly, lead 2 positive ion is also going to be forming white precipitate of PbCl2. The first analytical group of cation, the silver group, we have to add dilute HCl, and white precipitates are going to be obtained. So this means that the first group cations are present. Silver ion, lead 2 positive ion, or mercuric ion may be present here. We have to use dilute concentration. If we use higher concentration than 1 to 2 molar, the lead chloride precipitates are going to be redissolved. They are going to be soluble in the form of PbCl4 to negative ion. This complex ion is going to be soluble in water. We know that all are white precipitates. The first group cations are going to have their chlorides insoluble, and they all are white precipitates. We have to perform the distinguishing test with the addition of ammonium hydroxide to the white precipitate. After the addition of HCl into the original solution, white precipitates are being obtained for the Lead 2 positive ion means that lead chloride is formed. For the silver positive ion, we have silver chloride formed and it is white in color, white precipitates. And also mercuric chloride, that is white precipitate. So mercuric ion, silver ion, and lead 2 positive ion may be present. We have to distinguish these ions or these precipitates. How the white precipitate is going to be distinguished? We have to add ammonium hydroxide to the white precipitate. If the white precipitate is not soluble in ammonium hydroxide, we are going to say that lead 2 positive ions may be present. If we are performing the salt analysis and we have added the HCl into the original solution, we have obtained white precipitate, and after obtaining those white precipitate, we have to add ammonium hydroxide to the white precipitate. If those white precipitates are going to be soluble in ammonium hydroxide, in the addition of ammonium hydroxide, we are going to say that our salt contains silver positive ion. If in another experiment or for other students, we may say that if he added the HCl dilute into the original solution of salt, he has white precipitate. He is going to say that the first analytical group of cation may be present, and further he has to add the ammonium hydroxide to for the distinguishing test. If the white precipitates turns black, we may say that, or he may say that silver 2 positive ion is present in his given salt. So distinguishing test is being performed with the help of ammonium hydroxide. With the addition of ammonium hydroxide to the white precipitates, if precipitates are not soluble, silver lead 2 positive ion is present. If white precipitates with the addition of ammonium hydroxide is soluble, silver positive ion is present. If the white precipitate with the addition of ammonium hydroxide turns into black precipitate, we are going to say that silver mercuric positive ions are present in the given salt. Second analytical group of cation, basic radicals. In the original solution, we have to add dilute HCl and we have to pass H2S gas from the solution. If the first analytical group, we have observed no precipitation, this means that the first analytical group of cation are absent. Then we have to go for the second analytical group. With the addition of HCl and H2S gas, their precipitates are going to be obtained. Precipitates are going to be obtained for these cations. These all are going to show sulfides which are insoluble in water. These are going to show their sulfides which are insoluble in water, and they may have different color precipitates. Sulfides of group 2 cations have a specific color of their precipitates, means that if black precipitates are going to be formed reddish brown near to black precipitates, we are going to have bismuth, copper, mercuric, or lead 2 positive ion may be present. These are going to have sulfides, and these sulfides are black in color. When yellow precipitates means that the sulfides are yellow in color, we may have cadmium and SN4 positive ion. These cations, cadmium 2 positive ion and SN4 positive ions, are going to form yellow precipitates if we are going to add or HCl dilute and hydrogen sulfide gas into the original solution of salt. While we are going to add HCl dilute and H2S gas into the original solution, if you are going to obtain brown precipitate, the tin 2 positive ion may be present, and SNS, tin sulfide, is the brown precipitates. If red or orange precipitates are going to be formed, then we may have Sb3 positive ion. the third analytical group of cations means that systematically we have observed in an experiment that group 1 cations are absent, group 2 cations are also absent. We didn't have any precipitation in group number 1 or by the addition of HCl and H2S in group number 2. So we are going to add ammonium chloride and ammonium hydroxide in excess to the original solution, and if precipitations are going to be formed, this means that the third analytical group of cation is present. Group third, basic radicals. While the addition of ammonium chloride and ammonium hydroxide to the original solution, we are going to obtain green precipitate, white precipitate, or brown precipitate. Means that if the cations of third group are present, we are going to obtain these precipitates. If green precipitate is obtained, we may have Fe2 positive ion and chromium 3 positive ion. If white precipitate is going to be obtained, then aluminum 3 positive ion may be present in the given salt. If brown precipitate is obtained, we may have Fe3 positive ion present in our given salt. Remember that the ammonium hydroxide is the precipitating agent, or it is going to cause the precipitation of Fe3 positive ion, aluminum 3 positive ion, or chromium 3 positive ion, and Fe2 positive ion as their hydroxide. So the hydroxide FeOH2, ferrous hydroxide, is green in nature, green in color. Chromium hydroxide is also going to form green precipitate. Aluminum hydroxide is going to form as white precipitate, and ferric hydroxide is going to show brown precipitate. Distinguishing test for the third analytical group of cations. Addition of excess of sodium hydroxide is being used. For chromium 3 positive ion and Fe2 positive ion, it is used as a distinguishing test. And for aluminum 3 positive ion and Fe3 positive ion, it can be used as the confirmatory test for these cations. We have seen that by the addition of ammonium chloride and ammonium hydroxide to the original solution, green precipitate was obtained, and we were in a doubt that Fe2 positive ion or chromium 3 positive ion may be present, because these two ions are going to show green precipitates in the form of FeOH2, ferrous hydroxide, and chromium hydroxide. These two are green precipitates. We have to add sodium hydroxide in excess to the green precipitate. If the green precipitate remains insoluble, we can say that the ferrous hydroxide is not going to be solubilized by the excess of sodium hydroxide. So we are going to say that we have Fe2 positive ion present in our given salt. While performing the distinguishing test for the green precipitate, if with the addition of sodium hydroxide to the green precipitate are going to be soluble, this means that we may have chromium 3 positive ion and its green precipitate chromium hydroxide with the addition of excess of sodium hydroxide are going to be converted into the sodium chromide NaCrO2, which is soluble in water. So we can say sodium hydroxide addition will going to show that if the green precipitates are soluble, we may have chromium 3 positive ions. If with the addition of sodium hydroxide, the green precipitates are insoluble, we are going to have Fe2 positive ions. And similarly, we know that with the addition of ammonium chloride and ammonium hydroxide in group number 3 to the original solution, we may have brown precipitate. And brown precipitates are of FeOH3, ferric hydroxide. This is going to show that Fe3 positive ion is present in our given salt. We have to add excess of sodium hydroxide to the salt solution. We have to use a salt solution in another test tube, and we have to add excess of sodium hydroxide into it. There will be brown precipitate, and in the excess of sodium hydroxide, those brown precipitates are not going to be solubilized. So we have ferric hydroxide present, and these ferric hydroxides are are brown in nature and brown in color. So we may say that our salt contains ferric ion, Fe3 positive ion. If the addition of ammonium chloride and ammonium hydroxide to the original solution, group number 3, we have white precipitates. This means that aluminum ion may be present, and white precipitates are of aluminum hydroxide. How we are going to distinguish, or the confirmatory test for the aluminum 3 positive ion, we have to add excess of sodium hydroxide to the salt solution. When we are going to add excess of sodium hydroxide, first the white precipitates are going to appear, and with the addition of excess of sodium hydroxide, the white precipitates are going to be redissolved or solubilized again. So in the form of NaAlO2, sodium aluminate will going to be formed. First, aluminum hydroxide will going to be formed. That will be a white precipitate, and then with the addition of excess of sodium hydroxide, sodium aluminate will going to be formed. This means that the aluminum 3 positive ion may be present in the given salt. The fourth analytical group of cations, we have to add ammonium chloride, ammonium hydroxide to the original solution. Further, we have to pass hydrogen sulfide gas from that resulting solution. If the fourth group cations are present, the precipitation is going to occur. So this means that four group cations are there. The fourth analytical group of cations. In the fourth analytical group of cation, the group reagent which we have added into the original solution were ammonium chloride, ammonium hydroxide, and hydrogen sulfide gas. We are going to obtain the precipitates, the cations which are going to form precipitates, and these cations have sulfides insoluble. So we are using hydrogen sulfide gas in group number 4 to precipitate out the group 4 cation as their sulfides. If white precipitates are obtained, and we may have brick, flash, buff colored precipitates, and we may have black precipitates. Okay, for white precipitate obtained, we may infer that we have zinc 2 positive ion present, and with the addition of H2S, zinc reacts with the sulfide ion to form the zinc sulfide that is white in color. Zinc sulfide is insoluble in water, and it will going to be obtained as white precipitate. Similarly, Mn2 positive ion will going to form the buff colored precipitates as their sulfide. Manganese sulfide is buff colored. And similarly, nickel sulfide and cobalt sulfide, if these two cations are present in the given salt, with the addition of these reagents to the original solution, we may have ammonium chloride, ammonium hydroxide, and hydrogen sulfide. If nickel or cobalt ion are present in the given salt, we may have black precipitation. Black precipitates are of nickel sulfide and cobalt sulfide. The formula of sulfides are NiS and COS. How we are going to distinguish these cations? We have to use sodium hydroxide. We have to use sodium hydroxide. We are going to use sodium hydroxide, and we have to add sodium hydroxide to the salt solution. Okay, if we are going to add sodium hydroxide to the salt solution, if the white precipitates are obtained, and these white precipitates are going to be redissolved in the excess of sodium hydroxide. If you are going to add excess of sodium hydroxide, the white precipitates are going to be solubilized. This means that we have zinc 2 positive ion present. Similarly, if we are going to add sodium hydroxide to the salt solution, light brown color precipitates are going to be obtained, and in excess, these brown precipitates are not going to be soluble. So, Mn2 positive ion is going to be present in the given salt. Similarly, if sodium hydroxide is going to be added to the original solution, salt solution, if green precipitate are going to be obtained, we may have nickel 2 positive ion present, and if blue precipitates are obtained, we may have cobalt 2 positive ion present. So there are two stages in the group 4. First, the original group reagents were added. If white precipitate were there, zinc 2 positive ion was present in the given salt. If buff colored precipitate is going to be are going to be obtained, then we may have Mn2 positive ion present in the given salt. If black precipitate is going to be present there in the uh, after the addition of group reagent, black precipitates are obtained, we may have nickel 2 positive ion and cobalt 2 positive ion. And in the next stage or in the next step for these fourth group cations, we have to add sodium hydroxide to the salt solution. Remember that the salt solution, we have to add sodium hydroxide, white precipitates are going to be obtained. This means that zinc 2 positive ion is present, and these white precipitates are going to be redissolved with the excess addition of sodium hydroxide. If the addition of sodium hydroxide gives us brown precipitate, Mn2 positive ion is present. If the addition of sodium hydroxide gives us green precipitate, nickel 2 positive ion is present. And if the addition of sodium hydroxide to the original solution gives us blue precipitate, we may say that our salt contains cobalt 2 positive ions. Fifth analytical group of cations, basic radicals. We have to add ammonium chloride, ammonium hydroxide to the original solution, and with the resulting mixture, we also have to add ammonium carbonate. The fifth analytical group of cation are going to be precipitated with the help of carbonate ion. Their carbonates are insoluble in water. With the addition of After the addition of ammonium chloride, ammonium hydroxide, ammonium carbonate to the original solution, we are going to obtain white precipitate. This means that the fifth group cations, calcium ion, strontium ion, and barium ion may be present. We have to dissolve these white precipitate into acetic acid, and after dissolution, we have to add potassium chromate solution to the resulting solution, or to the dissolved precipitates. So with the addition of potassium chromate solution, if yellow precipitates are going to be obtained, this means that our salt contains barium 2 positive ion. If yellow coloration is obtained, no precipitate, only yellow coloration, this means that our salt contains the given salt contains calcium ion or strontium ion. The sixth analytical group of cation is being observed by the addition of ammonium chloride, ammonium hydroxide, and sodium hydrogen phosphate to the original solution. In the original solution, we have added ammonium chloride, ammonium hydroxide, and sodium hydrogen phosphate. If no precipitates are obtained, we may have ammonium ion, potassium ion, or sodium positive ions present. If white precipitate is going to be formed, this means that our given salt contains magnesium 2 positive ion. And now for the further identification, for the further analysis, we are going to add sodium hydroxide to the salt solution, and we have to heat that solution. If the salt solution on heating, the smell of ammonia is being produced. This means that the salt contains ammonium positive ion. If no smell of ammonia is observed, this means that potassium or sodium positive ion is present in our given salt. Remember that with the addition of group reagent, we have obtained white precipitate. In an experiment or in a way that the salt which we are analyzing, we have added the group reagent, group 6 reagents. We have obtained white precipitates, means that magnesium 2 positive ions may be present. Okay. And then after we have to add sodium hydroxide solution to the salt solution. And if white precipitates are going to be obtained with the addition of sodium hydroxide to the salt solution, we are going to say that our salt contain Mg2 positive ion, magnesium 2 positive ions.